Okay, so reductive amination in nature, we have seen that how uh, pyroxene phosphate works as an reducing or as agent, we can say reducing agent, and how to create carbon nitrogen single bond with the help of this pyroxene phosphate. Okay, so one more reaction occurs in nature. This one is the which is occur with the help of NADPH. So already we have seen the introduction for NADPH, which is reducing agent, and that one is isomer of NADPH is isomer of NADP. So all that mechanism or how these things are interrelated with it, that we have seen already. Okay, so here we are going to use this reaction, the true reductive amination using NADPH and ammonia. Okay, so these types of reductive amination happens in living system. So reversing the reaction makes an amino acid stereospecifically out of the alpha keto acid. Okay, so a lot of things we do concern with the amino acids. That means amino acids normally that one is utilized to make proteins in body, and protein is a very essential part of living organism. So all these things, everything we do learn in this chapter, that one is related to the how the living systems they do fulfill their requirements with the help of these different enzymes, how the metabolic system, how different reaction oxidation reduction they occurs in this inside the living system, living species, and which different catalyst, we can say catalyst, or which reagents they do help out all to do all this convergence. Okay, so in fact a complete cycle is usually set up whereby the one amino acid is converted to the equivalent alpha keto acid, while another alpha keto acid is converted to its equivalent amino acid. Okay, so everything is related. We are okay, so we are revolving around different amino acids. Here is glutamic acid is here. This is true transamination. Amino acids get used up making proteins, for example. So to keep life going, ammonia must be brought in form somewhere. Okay, the K amino acid is in this link is glutamic acid. So we'll see how glutamic acid will be synthesized with the help of NADPH. Okay, how what is the role of NADPH in synthesis of this amino acid named glutamic acid? A true reductive amination using NADPH and ammonia builds glutamic acid from alpha ketoglutarate acid. So here is alpha ketoglutarate acid and ammonia. Okay, how these two things react with each other. So conversion of this carbonyl compound and treatment of this carbonyl compound with ammonia, it generates the carbon nitrogen single bond. Okay, so carbon nitrogen single bond has been, it's a reductive amination we have done here with the help of NADPH. Okay, the other amino acids can now be made from glutamic acid transamination. Okay, at the end their useful life, at the end their useful life, they are transaminated back to glutamic acid. Okay, which in mammals at least gives its nitrogen to urea for excretion. So this is the scene, that means this are all, these are the reversible reactions. Okay, and we do see here alpha keto glutaric acid and ammonia reacts in presence of NADPH, they turn to the glutamic acid. Okay, and we can reversibly, this amino acid can reversibly can convert to this alpha ketoglutarate acid. Okay, so these things, but the just we are concerned here the role of NADPH. This same role in some cases this pyridoxal glutamate, that one is performing, and here NADPH is performing. Okay, this is concern about the reductive amination in nature. Next point, we are going to see that nature's acyl and equivalent. What is the nature's acyl and equivalent? So nature's acyl, again, this one is again one moiety, one enzyme we can say. So that one is helping out to do different organic, not organic, but some different transformations in a living organism. Okay, so this is nature's acyl and equivalent. D1 reagent is here, and is what is this acetylene equivalent? Nature's acetylene equivalent is nothing but the thiamine pyrophosphate. So here is the structure of thiamine pyrophosphate. Okay, it's thiamine molecule. Okay, so here is pyrimidine moiety, thiazole is here, sorry, and here is a pyrimidine. So and overall structure we call thiamine pyrophosphate. So thiamine pyrophosphate looks quite like nucleotide. It has two heterocycles ring, a pyrimidine similar to those found in DNA and thiazolium salt. This ring has been alkylated on nitrogen by the pyrimidine part of the molecule. Finally, there is a pyrophosphate attached to the thiazolium salt. Okay, this thiazolium salt, nitrogen possesses positive charge by an ethyl side chain. Okay, so how this reagent, this D1 reagent, how that one is performing its action in nature, we will see now in our next slide.